Alright, in this video, we will be looking at the reaction of alkanes. So we're going to look at three reactions of alkanes. We're going to look at combustion, cracking, and substitution. So when we say combustion, we mean burning. So alkanes, when they burn, they yield carbon dioxide and water. So the products of combustion for our hydrocarbons, carbon dioxide and water. And we need oxygen. So for it to burn, oxygen must be present. Now, if the oxygen is in sufficient supply, we will have complete combustion. So in complete combustion, the products are carbon dioxide and water. So it doesn't matter which hydrocarbon is undergoing combustion, the products are always the same. So whether it's ethane or butane, when you combust it, once the oxygen is in sufficient supply, we will get complete combustion. The products will be carbon dioxide and water. However, if the oxygen supply is not sufficient, then we, instead of carbon dioxide, we will get carbon monoxide and water. So combustion, all you're doing is reacting your hydrocarbon with water. If the oxygen supply is sufficient, you will get carbon dioxide. If it is insufficient, you will get carbon monoxide. So when it's sufficient, you have complete combustion. When it's insufficient, you have incomplete combustion. Now all we have to do is balance our equation. So with this one, we're going to balance the equation by doing carbon, hydrogen, and then we leave oxygen for last. So if you look, we have two carbons here, therefore we're going to leave two carbons here. We have 6 hydrogen here, and so we're going to need 3 here. 3 twos, 6. That leaves us with that now leaves us just with oxygen. If you look here, 2 twos, 4, and 3 ones, 3. So we have a total of 7 oxygen. So for this one, 7 is an odd number. So it's 3.5 times 2 that will actually give you 7. But we are not going to use a decimal. What we do is use a fraction. So 3.5 times 2 will give you 7. Or you can do it as an improper fraction. 3 to 6, 6 and 1 is 7. So you can put 7 over 2, or if you want to put the 3.5. So when you're doing combustion, once you get an odd number, to get it into an improper fraction, just put it over 2. So if you've got 9 oxygen, you just come over here and put 9 over 2. If you've got 15, it's 15 over 2. Once it's an odd number, you just put it over 2. If it's an even number like 10, then of course, 2 times 5 is 10. So you just put 5. Let's look at the next example. Butane plus oxygen, it's complete combustion, so you will get carbon dioxide and water. 4 carbons is here, so we need 4 there. 10 hydrogen, so we need a 5 there. 5 twos, 10. How many oxygen do we have? 4 twos, 8. 5 ones, 5. 8 and 5 is 13. 13 is an odd number. Once it's an odd number, all we need to do to balance is 13 over 2. If you check it, 13 over 2 is 6.5. 6.5 times 2 is 30. So once you get an odd number, just put it over 2. This is specific to combustion and with oxygen. So you get 13 oxygen over here, let's put 13 over 2, because 13 over 2, that is 6.5, and 6.5 times 2 is 30. Let's check down here again. As I said, it doesn't matter the hydrocarbon, so we are using but the same. What we are looking at is if the oxygen is in sufficient supply. If it's insufficient, you will get carbon monoxide instead of carbon dioxide. Alright, so again, 2 carbons here, you will need 2 there. 6 hydrogen, so you will need a 3 there. So 3 2s, 6 hydrogen. Alright. Now for oxygen. 3 1s, 3, 2 1s, 2, 3 and 2 is 5. So that's 5 over 2. 4 carbon, 4 carbon, 10 hydrogen, 5 hydrogen. 4 1s 4, 5 1s 5. 5 and 4 is 9, so it would be 9 over 2. Let's try with an even number. Let's try propane. C3H6. No, that's not propane, that's propene. C3H8 plus oxygen. And it's insufficient, so it would be carbon monoxide and water. 3 carbons, 3 carbon, 8. So that would be 4. You have 4 2s, 8. 11. 3 1s, 3. 4 1s, 4. 4 and 3, 7. 7 over 2. Let me put it here. So this part is the incomplete. So C3H8 plus O2 3 carbons, 8 hydrogen. So we need 4 hydrogen. Alright, so 3 2 6 oxygen, 4 1s 4. So 6 oxygen is here and 4 oxygen is here. So 6 plus 4 is 10. And 2 times 5 is 10. So when it's an even number, there will not be the need for a fraction. Because 2 times 5 is 10. Simple as that. But once you get an odd number, you just put it over 2 and they are good. So this is it for combustion. Just write the equation and balance it. Next reaction is cracking. Alright, so for cracking, we will have our large saturated hydrocarbon, which is the alkane. We're doing reactions of alkanes, right? So cracking, we're breaking up our alkanes, our large alkanes, into smaller ones. But we must get unsaturated, including unsaturated. So when you crack an alkane, you must get a smaller alkane as well as an alkene. Alright, so you have your large hydrocarbon, which is the alkane. You crack it, you'll get a smaller alkane and then alkene. I'm just going to use butane for example. So butane is C4H10. So that is butane, C4H10. If we crack it, you can choose where I want to crack it. Let's say we crack it in the middle. So if you crack it here, it means that we must get 2 fragments, each with 2 carbons. Right? And we said one of them must be an alkene. Now the functional group for alkene is carbon to carbon double bond. So we put in that to make it an alkene. So whenever you crack an alkane, you must get a small alkane and an alkene. And we know that carbon must have 4 bonds. Each carbon atom must have 4 bonds. This already has 2, so that is that. And then you put on your hydrogens. So there we go, we get our alkane and our alkene. This would be ethane and this would be ethene. And we cracked butane, which is C4H10. Now check back your molecule to see if everything adds up back to C4H10. So 1, 2, 3, 4 carbons, so the C4 is good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. So the products must equal back to the reactant. C4H10, it must add back to C4H10. That is why you have to get the alkene, because if this was also an alkane, we would have get a total of 12 hydrogen, and it would not work. So you could not start with C4H10, break it, and then get C4H12. So the formation of the alkene keeps it at C4, keeps the total product as C4H10. If this was an alkane, this would mean that this double bond would not be there. You would need a hydrogen here and a hydrogen here. That would make it C4H12. Now you don't have to do it in terms of this chapter. You can do it using the molecular formula. So if I crack the alkane, right? Let's say again we are using the 2 carbons, right? Both of them would be C2. Now we know the general formula for alkane is CnH2n plus 2. That means if your alkane has 2 carbons, it must have 6 hydrogen. And we know alkene is CnH2n. So if you have 2 carbons, the amount of hydrogen must be 4. So in alkenes, the amount of hydrogen is twice as much as carbon. And we can add 2, 2, 4, 6 and 4 is 10. So just remember, when you crack an alkane, you must get an alkene, you must get an alkane. So let's look at it in practical terms. This is C4H10, this is butane. If we break it here, right? This is C2. This carbon atom has 1, 2, 3 bond. This carbon atom has 1, 2, 3 bond. This carbon atom has 1, 2, 3 bond. This has 1, 2, 3. This is not attached to anything. Good. So you can see that something is off because this carbon is short of a bond. So some rearrangement will need to happen. So remember, we must have an alkane and an alkene. So let's just break it. So this would be ethane now. We get our C2H6. That's good. But as you can see, we have 2 carbons, but only 4 hydrogens. Right? And each carbon needs to have 4 bonds. So this extra bond that is remaining, we are going to use it to form a bond between these 2 carbon atoms. Remember, there's a bond between them already, so we're forming a next bond now. And that is why we need to get the alkene. So now each carbon atom has 4 bonds. So whenever you crack an alkane, you will get an alkene, as well as you will get a smaller alkane, ethane, and an alkene. So you must always get an alkane and an alkene. Let's try the next example. Alright, let's crack pentane, heptane. Alright, so using heptane as example, show how you can get 3 products from the cracking of heptane. So heptane is C3, is C7, H, 16. So they are asking you to crack it to get 3 products. So not 2 products this time, 3 products. You have 7 carbons. You can choose how much each fragment have. So let's say C2, and C3. So let's say we break it. So we have 3 fragments, 2 carbons, and 4 carbons. Remember, one of them must be an alkene. So let's say this one is the alkene, right? Alkene, if it has 2 carbons, it must have 4 hydrogen, right? So that means, let's just make this one the alkene. That will be C2H6. Now let's just, once you do the first 2, just check how much hydrogen you have left. So we have a total of 16 hydrogen. We have made the first fragment the alkane and the second fragment the alkene. How many hydrogens have we used? 6 and 4 is 10. So we have used 10 hydrogens. So we have a total of 6 hydrogen. So this fragment has to have 6 hydrogen. That means we can only have 1 alkane. So when they ask you to crack an alkane to give us 3 products, two of them must be alkene and one must be alkane. So even if you are asked to draw the structures, you can do it using the molecular formula. It's much easier to see it and then you can draw it. So let's do it again. Let's remove the hydrogen. No. And let's put it back. C2H6. Let's see if we can crack it in different sections. So let's say one fragment is C4 this time. That means the next one will have to be C2 and just C. So again, let's say this one is the alkane. If it's C4, so you can choose, it's up to you. The question says just give them 3 products. It doesn't matter the size of each fragment. Just make sure that you can get 3 products. So C4, if it's C4 and you want the C4 to be an alkane, it's C4H10. This definitely has to be the alkene because you cannot have an alkene with just 1 carbons. And if it's C2H4, 10 and 4, that's 14. Oh, yes, good. Wait, yes. So remember I said, when they ask you to crack, so let me just do it and then explain. This would have to be an alkane, right? But at the moment, if this is an alkane, it's supposed to be CH4. But if you check, 10 and 4 is 14, and 4 that's 18. We must not have more than 16 hydrogens. What's the problem? This is an alkane, this is an alkane. Remember I said, once they ask for 3 products, 2 of them must be an alkene. So for it to work, remember, because this is 1 carbon, it has to be an alkane. So we cannot make this an alkane. We can only have 1 alkane. So this must be C4H8. And so no, this can be CH4. 8 and 4, 12, 12 and 4, 16. So just make a note. Once they ask for 3 products, 2 of them must be an alkene. So in terms of structure, 1, 2, 3, 4, 5, 6, 7. Using the first example, we will break it between these carbons 2 and 3 and between carbons 4 and 5. And so the fragments will get, alright, and the next 2, and then one with 3 carbons. I will say we are making 2 of them an alkene. The C3 is an alkene. Remember, pay careful attention to the double bond. The carbon must only have 4 bonds around it, so you cannot put the hydrogen there. And you always check to make sure whatever is here, it adds up to what is up here. So up here we have C7H16, and down here we have C2, C2H6, C2H4, and here we have C3H6, 2, 4, 7, that's C7, 6 and 4, 10, 10 and 6, 16. So that is cracking. Oh yeah, there are 2. This is how you will represent it. But in terms of the process, you have thermal cracking and catalytic cracking. So as it suggests, thermal means heat and catalytic means the use of catalyst. But in terms of doing it, this is how you will show the equations. So the final reaction now is substitution. Now I can say halogenation because we will be adding a halogen. So we're doing the halogenation of alkanes. Right? And so we can also call it substitution. And let's explain why. Let's look at an alkane. So let's look at methane, CH4. And remember we said carbon always form 4 bonds. And the example we are going to use is the reaction of methane with chlorine. So we have methane with chlorine. And what we are going to try and do now, let's use something as chlorine, alright? Remember, chlorine is a diatomic molecule. I'm going to use this as chlorine. So this is chlorine, Cl2, and this is methane. Carbon only form 4 bonds. At the moment, carbon does have 4 bonds. So, chlorine, if it wants to be attached to this carbon, something has to come off because carbon is not going to form 5 bonds. Carbon is tetravalent. 4 valence electron, it forms 4 bonds, not going to form 5 bonds. So, what will have to happen? One of these hydrogens will have to come off. That now creates a vacancy for one of these chlorine atoms. Good? So both chlorines are not going on the carbon atom. One of them is going. So the chlorine to chlorine bond also has to break. Alright? So one hydrogen comes off, that is it. The chlorine to chlorine bond, it breaks. Good? When it breaks, this chlorine, one chlorine, goes on the carbon atom, and the other chlorine now forms a bond with the hydrogen. So you have hydrogen and chlorine, HCl, hydrogen chloride. And then you have chlorine and methane, that is chloromethane. So you have chloromethane and hydrogen chloride. When HCl is a gas, it's hydrogen chloride. You dissolve it in water, that's hydrochloric acid. So I just showed you what happened, right? You have CH4 and you have the molecule of chlorine. One of these chlorine needs to be attached to the carbon. Carbon only forms 4 bonds, it already has 4 bonds. As the name suggests, substitution, you are substituting. One of these hydrogen has to come off. Good? So, one of the hydrogen, it has to come off. These chlorine are bonded together. That means the bond has to break. Good? So these 2 chlorine have to separate. So one hydrogen comes off and both chlorine atoms have now separated. One of them will now move over to carbon, and the next one now will form a bond with hydrogen. And that's what happened. Now in terms of the equation, all you're going to write is CH3, because if you have CH4, we know that one hydrogen has to come off to make space for chlorine. So one hydrogen comes off and one chlorine goes on. So you start out with CH4, but you end up with CH3Cl because one hydrogen goes off, one comes on, and the chlorine comes on. And we know that we started out with 2 chlorine atoms. One of those chlorine atoms we combine with the hydrogen atom that came off. And so you get HCl. And that's it, substitution. No, this reaction, alkanes, because they are saturated, they are unreactive, unlike your alkenes. And so this reaction, it needs UV light to start the process. So if they ask you for the condition for this reaction, the condition for this reaction is UV light. Now this is for the CSEC level. At the basic organic chemistry level, all you need to know is the introduction. At A level, you will need to know about reaction mechanisms. But this video is for high school, right? Not A level, advanced chemistry. So you just need to know the equation. You're just substituting a chlorine for a hydrogen. Now, we can get tetrachloromethane. This is just chloromethane. The reaction don't have to stop there. So if you have a molecule of chloromethane, right, you can have a next molecule of chlorine that reacts with your chloromethane. Again, what is going to happen? The same thing as before. A hydrogen comes off. If a hydrogen comes off, how much you have? CH3. If one comes off, that means you have CH2. It already had one chlorine atom, right? So if a next chlorine atom comes in, it is now Cl2. So now you have CH2, Cl2. Let's show it. Plus hydrogen goes with chlorine. Let's do it here. CH3. You add CH4. Add CH4 again because CH4 is up here. You have CH3Cl. Right? You react it with a molecule of chlorine again. So this is a different reaction. The first reaction, we just substituted one chlorine for one hydrogen. So we get chloromethane. Now we're doing the reaction again with chloromethane and the next molecule of chlorine. So again, one hydrogen will come off and this bond break and the chlorine comes here. That is how we get the 2 chlorine. And of course, the hydrogen that comes off goes with that chlorine. So you get dichloromethane, right? And of course we can go again. If you get a next molecule of chlorine, one hydrogen comes off, the chlorine goes on. So let's start with CH2Cl2 now. So CH2Cl2 reacted with a molecule of chlorine, you will get CHCl3 plus HCl. Each step is the same thing. You are removing an hydrogen and putting on a chlorine. So now you have CHCl3 plus Cl2. You will get what? CCl4 plus HCl. So you have carbon tetrachloride or tetrachloromethane. You stick with tetrachloromethane. It's organic chemistry. And that's it. So let's write an equation. So you have methane and you react it with chlorine. And you get tetrachloromethane plus HCl. Let's balance the equation. So you have carbon, you have methane with chlorine, you get tetrachloromethane plus HCl. 1 carbon, 1 carbon. 4 chlorine is here. 4 chlorine plus 1, that would give you 5, but you cannot put 5 right? 2 times what is 5, it wouldn't work. So let's do hydrogen. 4 hydrogen here, we put a 4 there. Now, how many chlorine do we have over here? 4, and 4 times 1 is 4, 4 and 4 is 8. 2 times 4 is 8. Now, look at our different steps. Starting from the first substitution to the second, to the third, to the fourth. How many molecules of chlorine did we use? 1, 2, 3, 4. So this was, I did all the steps for each substitution, and we used a total of 4 chlorine molecules. This is one equation going from methane to tetrachloromethane. But this is a stepwise process, doing each substitution. Right? So this equation is from methane to chloromethane. This one is from chloromethane to dichloromethane, from dichloromethane to trichloromethane, and from trichloromethane to tetrachloromethane. This one now is showing the entire thing from methane going directly to tetrachloromethane. And you can see that if you add up the 4 steps, we use 4 chlorine. Add up the 4 steps, we get 1, 2, 3, 4 molecules of HCl. And don't forget to put in the UV light. So once you are doing substitution, you must put in the UV light. And that's substitution for you. So the 3 reactions of alkanes: substitution, cracking, and combustion. So that's it for alkanes. We have looked at naming alkanes, looked at isomers, and now we have looked at the reactions of alkanes. So in the next video, we are moving on to alkenes. So study these reactions and know them, because when you get to alkenes, alcohols, you'll probably forget about alkenes. So study them and know them. Look at how to name your alkanes. So that's it for this video. If you have any question, you can ask in the comment section. And again, as always, by now, if you are watching, you know that I will post questions to my Instagram page, which is Poetic1111. Questions and answers. I might take a longer time to do a video with working out the questions and the answers. But for now, I will post questions and answers to the Instagram page. So that's it for this video. Remember to like and subscribe and share.